This video, I'm going to talk about making a grouped frequency histogram. We're also going to find relative frequency and cumulative frequency when we do this. So let's get started. I've gone ahead and put the data sets into my calculator to help me get started. To do that, go into Stat, Edit, and make sure that you type all the data into a single column. So I have 4 columns here for my 4 problems that I'm going to do. It makes your life easier if you sort the column of data before you get started, especially if you're going to try and count things by hand. So let's go ahead and show you how to do that. If you come into your stat menu, there's an option right there that says sort ascending, and we just do second L1 for list 1, and when I come back now here, then list 1 is sorted for me from lowest to highest value. I could go and manually count this, but it's easier for me to set up a histogram and let the computer calculate this for me. So the calculator do that calculation. So I'm going to go into second stat plot, turn these plots on here, and I'm going to choose a histogram here and go to my window, and I'm going to let my x min be my minimum x value. I chose my x max to be my one more than my maximum x value so that you can see the right side of the bar. It really doesn't matter that I put that extra one in there unless it forces the calculator to draw another class, which it shouldn't, because there should be no data over there, but you can just ignore that if it does. And then my class width is going to be the difference between lower limits or the difference between upper limits. So 50 minus 45 is going to be 5, and I put that in for my X scale. We call that our bin size as well. And then I'm going to graph this. Make sure that you have all other functions turned off before you do this, so you don't get any functions over top of this. And I'm going to now trace right here, and I'm just going to follow along here, and this one has 5 things. I'm looking at this n value, and then I'm going to arrow to the right, and then I'm going to have 2, then I'm going to have 5, then I'm going to have 3, then 2, then 3, then 2, and then finally 3. If I add up all of these values, 7, 12, 15, 17, 20, 22, 25, I get my n value of 25 that's here. So now I'm going to calculate 5 over 25. And that's 0.2. So anywhere that I see a 5 in the list, I can put 0.2 for the f divided by n. 2 divided by 25 is going to be 0.08. So anywhere there's a 2 in the list, 0.08, 0.08, and 3 divided by 25 is going to be 0.12. Anywhere there's a 3 in the list, I can do that. All of these f divided by n's, if I add them together, should give me 1. And my sum, I'm just going to add 5 plus 2 is 7, plus 5 is 12, plus 3 is 15, plus 2 is 17, plus 3 is 20, plus 2 is 22, plus 3 is 25. And when I add all of this is called cumulative frequency, and my cumulative frequency for all of the groups should add up to be my n value. So cumulative frequency has to do with the number of things that are less than or equal to that group. Now let's move on to the second one here. I really don't need to sort the list. What I do need to do though is I need to go into here and I need to change from L1 to L2 for my data set. And I need to change my window so that the lower bound now is 3. The upper bound now is, I'll say 10. And my bins are a size of 2. I'm going to graph that and trace here. And that's 3, 13. It's off the chart. 7 and 1. So that adds up to be 3, 16, 23, 24, which is what I have here. I have 2 by 12 is 24. Now let's look at if I have 3 divided by 24, it's going to give me 0.125. 13 divided by 24. It's going to be, and I'm going to round this to 3 decimal places, 0.542. 7 divided by 24, it's 0.292, and 1 divided by 24 is going to be 0.042. So it's going to be off just a little bit from adding up to 100% because of this rounding. But if I had written it as fractions, for instance, as 3 over 24 is 1/8, 13 over 24, 7 over 24, and 1 over 24, then it would add together exactly 3 and 13 is 16, and 7 is 23, and 1 is 24. So be careful with your decimal approximations. That it's not always going to add up to be 1, but the fractions should always add up to be exactly 1. Let's go ahead and look at this next one here. Stat plot. Let's change this to L3. I'm going to change my window again so that my minimum now is 0 and my maximum is 336. So let's make my max 349. It's the top of my bin. And my scale, I'm going to go by 50s. And let's graph that. Trace. So that's 2. Then 4. 4, 4. 2, 1. And 3, like so. And I don't think that I missed anything there. Nope, I did not. So 2 plus 4 is 6, plus 4 is 10, plus 4 is 14, plus 2 is 16, plus 1 is 17, plus 3 is 20. I do have 20 values. 4 by 5 is 20. So 2 divided by 20 is 1/10. 1 divided by 20 is 0.05. This is 2.1, and then this is 0.15. So if I add all those together, that's exactly 1. Last one here is going to be in 4 for me. And I'm going to have my window start at 60 and go to 100 and by tens. I'm going to graph and then trace. And there's going to be 3, 12, 7, and 2. This is 3, 15, 22, and 24. This is 2 by 12. It is 24. 3 divided by 24 is going to be 1/8. 12 divided by 24 is 1/2. 7 over 24. 2 over 24 is a 12th. So I'm just leaving those that way because the decimals are not going to add up exactly. And you can get the decimal approximations for those if you would like. There are other tools, other analysis tools that you can use to do the same thing. I may make another video in the future on these same problems and show you how to do them in Excel, and maybe another video that shows you how to do them with StatCrunch. The only difference with how I did it with the calculator and doing it by hand, since I did most of this by hand, is that by hand you'd actually have to manually sort them. You might even want to make a stem leaf plot to help you sort them. And then you would have to manually count and cross off from the list the ones that are in each group. So the calculator just helped you a little bit in getting your bins and counting how many were in each bin. Usually we are going to be using this data to make what's called a frequency histogram or a relative frequency histogram. Every once in a while we'll do a cumulative frequency histogram. So that is why we were interested in getting these 3 columns here: frequency, relative frequency, and cumulative frequency, and to get these bins because we will be using them to plot these histograms in the future. Okay, that's it for this video. Come back next time and we will talk about another type of data analysis.